Hello and welcome everyone to the XYZ Ceramics and Digital Fabrication Symposium. Thank you all for joining us. My name is Matt Karras. I teach here in the ceramics program at Concordia University, and I'll be your virtual host for this event. The symposium accompanies this year's Virginia McClure Ceramics Biennale and brings together ceramic artists Harrow, Eliza Au, Emre Can, Jeanne Quinn, and myself, Matt Karras, together for discussion. There are many people to thank for this. I'd like to start by thanking Troy McClure for generously supporting the McClure Gallery and the Biennial. I'd also like to thank the show's curator, Amélie Proulx, the Westmount Visual Arts Center and their staff. Thank you, Natasha Reed, Barbara Wisniewski, and Renee Duval. Centre Materia, merci Guy Langelvin, and the Maison des métiers d'art, merci Thierry Plante-Dubé. I'd also like to thank the Office of Research and Graduate Studies at Concordia University, the Canada Council for the Arts, the Conseil des Arts et des Lettres du Québec, and the Conseil des Arts de Montréal. And I'd certainly like to thank Eliza Au for sharing her time and ideas with us here today. Thank you so much, Eliza. As the virtual hosts of this visit, I'd like to begin by acknowledging that Concordia University is located on unceded Indigenous lands. The Kanien'kehá:ka Nation is recognized as the custodians of the lands and waters on which we gather today. Chochega, Montreal, is historically known as a gathering place for many First Nations. Today, it is home to a diverse population of Indigenous and other peoples. We respect the continued connections with the past, present, and future in our ongoing relationships with Indigenous and other peoples within the Montreal community. If you have questions during today's demo, please pose them in the chat and we will parse through and answer questions at the end of the Zoom. For now, I'd ask that you all keep yourselves muted to avoid any background noise. And just so you know, we are recording this event. And now to introduce our guest. On behalf of the ceramics program, I'm very pleased to welcome Eliza Au. Eliza is an artist originally from Vancouver, BC in Canada. Eliza has exhibited extensively both nationally and internationally and has taught in Canada, the United States, and internationally at various institutions, including Emily Carr, the Alberta College of Art and Design, Monmouth College, the University of Iowa, and the Alfred Kaffa, which is the Central Academy of Fine Arts program in Beijing, China. Eliza is currently assistant professor of ceramics at the University of North Texas. Today, Eliza is going to be demonstrating the process that she uses in making some of the forms that are on view at the McClure Gallery right now. Eliza, hello. Thank you for joining us.
Great. Thank you for having me. And I really need to say a huge thank you to Matt and Amélie and definitely everyone who has helped organize this symposium. So it's just been wonderful being part of it and also seeing the other demos as well. So I think I'll start with a slide presentation. And here. Great. So I'd like to just go through a slide presentation first. And then I also have a video that's part of this, so you can see how I actually make the molds for my work. And then after that, I'm going to show you some objects live in my studio. And then I'll do a live demo of pressing one of my molds. So just getting started with this slide lecture. So obviously it's more of a technical lecture. I'm not really going to talk too much about the concepts of that. But so just as an introduction, I think I've been working with CAD for about 15 years now-ish. So right when I got out from undergrad, you know, I started learning Rhino CAD, which was around 2005. So at that time, actually, I was just using it to make basically line drawings, you know, that I would basically multiply and make patterns. So it was really just a sketchbook for drawing out kind of ideas very accurately and very fast. As most people know, like drawing by hand, if you want to draw like the same pattern motif over 1,000 times, it's going to take you a really long time. So CAD just really allowed me to work like really super efficiently to make complex forms. So this is a slide of more recently when I was in China about 2 years ago. And I was making these porcelain tiles, which were fired on a shrink slab. You can see maybe closer to me on my right side, there's a piece of clay that's just a slab, and then the lattice form is on top of that. So it has to be fired on a shrink slab, obviously, so it shrinks all together, and then the lattice form doesn't grab on anything or kind of deform as well. So anyways, there's always been an element of 2D basically transformed into 3D. That's often like a lattice form as well. So in China, I had to really figure out how to really work with this type of clay, because porcelain can really warp a lot. And it definitely, if you tried to just build this whole thing green, basically, wet clay to wet clay, as in a 3-dimensional form, it would just collapse in the kiln. So what I did was, I made these tiles. These are all high fired to about, I think it's close to cone 13, over cone 11, just flat. So basically the form is quite solidified, or it's not going to move. And then I slot everything together, and it's glazed at a low temperature with a low temperature glaze. So everything basically sticks together. So that's actually the main way that I've worked a lot in the past maybe 4 years or 5 years ish. Before that, I'd done like quite a few other things in terms of making these forms. So this is it in the kiln. You can see that on the left side, I've just used bricks to prop it up. And then very gently sliding the slotted forms into each other, right? Sometimes touching it up with some glazes in some parts, and then very gently pushing the whole kiln car into the kiln as well. So you can see that there's 2 other pieces that are also on that top bed. Also, they're just slotted together very gently together. And then, when it's in the kiln and it gets fired, all the glaze is basically sticking everything together. So here is some of the final products of that firing here. So you can see there are these round rondelle forms, and then there is this more rectangular forms that are slotted in there that basically keep it together. So it's pretty time intensive, to make these forms. It can be somewhere from more than a month or a couple of months, depending on how many models or patterns I need to make. So for instance, this one is 2 patterns, right? There's a circle, and then there's a rectangular one, right? So that's actually not that many shapes. If I have to make a shape, or a form that has like maybe 6 to 7, maybe even more than that, like every single different shape needs to have a different mold. I can't just make one big mold and then cut it into different shapes. That doesn't work. So it's very particular in how aesthetically it looks. Like I have to design the pattern to fit that rectangular or fit that oval shape. So that, obviously that plays a big part in that as well. So same thing with this bowl like sculpture here, right? So each of those circles, they're all different molds. The side piece is one kind of shape as well. So, I was really interested in how kind of light would be able to pass through these forms. And, the idea of kind of defying ceramics and defying gravity in some sort of way creates this element of wonder. So this type of form actually is called slice forms. And if people are interested, they could look it up on the internet. So slice forms is a method where you can draw something 3-dimensional in CAD and basically put it into this program, and then it will slice it up, and then you can basically create a slotted form from that. I believe it's most often used in furniture design, maybe architecture as well. That is most common. But anyways, I was also interested, obviously, it's this 2D to 3D kind of method as well. So this is just a breakdown of how I create things. So you can see that design. So RhinoCAD, obviously I use that one the most. Illustrator, Fusion 360. And then there might be like 1 or 2 programs, but RhinoCAD is definitely the most used program that I use. So prototype and testing, so kind of cardboard or 3D printed models as well. For a kind of a current project that I'm doing, I also, I physically make the plaster mold, and I go through the whole process, like and it's like, that's not the final mold. And then I make a mold again. Right. So usually in the prototype and testing method, because I'm working with molds, I can produce that module itself and produce it like basically over like a couple times or more, and glaze fire it everything like really roughly to figure out what works. And then after that, basically I'm going into production of many objects. So mold making, obviously mold making in plaster, I do an air compression mold. Production in clay, press molding or slip casting. So actually I have not been doing slip casting actually for quite a long time. The lattice forms that I'm making are actually all press molded and hand built. More recently, I am combining slip casting with press molded lattices. But I'll talk about that maybe a little bit later on as well. Installation in hardware, modified hardware or custom 3D printed hardware. So the 3D printed hardware, maybe in the last 2 years-ish, I've been doing a lot more on that. So, you know, it's always been very difficult for me to find specific hardware for my work, just because, you know, in terms of attaching it or hanging it and stuff like that. So it's, you know, before I've, you know, bought hardware, I've modified it and it's like, okay. But, you know, the 3D printing has really allowed me to really customize the way that I can put things together. And that's pretty huge because I'm not limited to whatever is mass produced. Okay, so designing the template and the pattern, I'm going to use one of my slot sculptures just to give you an example. So this is just a basic shape drawn in RhinoCAD. So just a, you know, basic sort of circle. So generally, if you look at my forms, like the whole big form is quite a simple shape. So it's usually like a box or like a cube, sorry, box and cube are same. A sphere or a round sphere or like kind of like a column, right? But then what it's actually made of or the actual form inside itself is very complex. So this is actually a slicer for Fusion 360. If anyone is interested in this program, I believe this might be actually part of the actual Fusion 360 software now. I think it might have just all been combined. But if you Google this, I think something will come up that you can somehow find the software. So anyways, it's really great because you can import your shape as an STL. And then you can slice it in many sort of different ways. So you can see here in the slicer program, right, you can see what kind of, how many like slices that you want in the X and then the Y axis as well. And then it will give you actually a pattern you can see on the right as a PDF. So, so I'm going to save this as a PDF. You can see here, it's all marked as well. And, you know, you can set actually also the thickness of your material and also the width of the slot as well. So I take these drawings and here you can see that it's imported into Illustrator here and save it as an AI file. So I take this AI file and then I open it up in Rhino. So you can see that the AI file is now opened in RhinoCAD. And then once I have this basic template, I can draw a pattern over it. So you can see this is actually the pattern for one of my pieces. I can just overlay it on top. And then I use a command called pipe to make basically a round tubing over kind of everything. So just in terms of like the lines where the blue lines and then the black lines intersect, right? I can also trim them, right? Because I do want that slot right there to fit the other tile into it. So you can see here, the 3D model is drawn over the lines. The slots are double checked to make sure that they're a little wider for the material for tolerance. Yeah. So yeah, so working with a lot of modules and things that fit together, I've really learned that you need tolerance more than you think you would need. Okay, so you never, it's not like a piece of wood or a piece of paper where it's flexible. Or, you know, it's obviously it's very difficult to grind a little bit off. So, you know, if it's 1 centimeter, then you need to make that slot like 1.2, 1.3 or something like that to really give a generous sort of width. So another thing is when you're slotting all of these objects together, you know, each of them do have a bit of deformity. So, you know, if one is kind of deformed, you know, and then you're putting in that last piece, the slot may be kind of too small because everything is kind of offset as well. So it's a very tricky balance in terms of, you know, putting all of these together and also supporting them as well, because, you know, this is a round object. So, you know, you have to be really careful in how you're putting it together, because it's not like a cube where everything can sit on the table. So here's the final piece here. You can see it's slotted together. I think there's maybe 4 different sort of shapes that are part of this as well. So I think when I supported this, I just used bricks and kind of wadding to put it together. But you know, you can also make another actual clay form to kind of hold it in place as well. Okay, so talking about models and also pattern plates as well. So, you know, how do I make that original model? So I've had a lot of different ways that I've made my models. Obviously, there's cardboard shapes cut by hand or laser engraver, testing for fit only, 3D printing small scale models, 3D printing pattern plates, resin or FDM, which is a filament printer, CNC engraving pattern plates out of wood or also foam. So these are all things that I have done before. Most recently, I have been mostly doing filament printing. That's just been the most easiest. I do own like several printers at home. So it's just most convenient for me, because I can start the printer, go to bed, and then come back the next morning, and hopefully it's turned out. So, and it's relatively, you know, I'd say relatively fast, which, you know, it can be a little bit depending on who you talk to. So, so these are just some ways of kind of thinking about different forms or using that idea of slice forms to create a shape. So you can see that there's some cardboard shapes here, you know, that are slotted together in some ways. So, you know, I can use a piece of cardboard. On the left, you can see a piece of foam core as well to give that thickness, right? So obviously it's very touchy when those tiles are being slotted together, because, you know, if you bend it too much in one way, it does snap and it does break. So here's the piece here. You can see it's slotted together in several places, and then it was I think I glazed it down kind of like flat as well. So that's a example of how something, you know, that is made out of foam core or kind of cardboard eventually is translated into clay. Okay, so 3D printed small scale models you can see here. So more kind of testing of how things would go together. So I was interested in making this form with tiles that were almost like H-shaped, that you could kind of stack on top of each other. The one on the bottom kind of right here was another idea of, you know, kind of making this shape on the kind of top middle here, this kind of cross shape. So I was interested in actually Japanese joinery. I still am kind of, but, you know, and how things can basically fit together without screws or kind of nails. It's the shape itself that kind of holds it together. Okay, so this is the FDM printer or filament printer, if people are not familiar with that. This is, I think, my husband's. It was his original kind of small one here. So you can see that it's, you know, building up layers. It's almost like this toothpaste tube that's squeezing out plastic back and forth over and over to basically create this sort of pattern plate you can see right there. So yeah. Okay, so 3D printing basics. This is a slide that I like to show my students when I'm talking about 3D printing. I'm just going to really summarize here. But basically, you know, you have a CAD file. Obviously, you're drawing your shape, and then you save it as SDL format. And then there's a the second one here is a slicing program, basically that slices it up into layers, which, you know, and also writes the G code. So then it gets put into some sort of SD card or memory card, which actually gets inserted into the machine. The machine prints your work, and obviously there's a final object that comes out from that. Okay, so, you know, this is the a file for an FDM model, actually the one that was on the printer previously here. So you can see that, you know, there's the pattern, which is then piped and actually has some sort of backing to it to make it easier to pull out from the mold. So you can see the printed object here, right? So, I've printed in many different ways, without that backing, but with that backing, it's a little easier for me to cast it because, the plaster won't actually go underneath the little sort of seam, and I kind of get a little bit of a cleaner line as well. More models that were 3D printed as well. So making kind of larger pattern shapes on the 3D printer, I like to divide it up into several sections here. So you can see on the right that this particular form was printed in 4 sections. And then the lines that connect them together, you can see that they're not straight, right? So because they are more of a zigzag line, there's better registration on how it fits together as well. SLA printing model. So this was out of a resin printer when I was living in China as well. So that's another way of printing. It does give like a really smooth surface. I don't have access to a resin printer that is really large. That's the thing with that type of printing. But it does give like a really nice smooth surface that filament printing doesn't necessarily give you. Okay, so a little bit about the way that I make my patterns. There's different ways that I actually draw, like just design-wise, that I think about my patterns. This was for one piece that I just, made a line and basically repeated it, just arrayed it. So just repeated it in a line and then copied it and then just turned it the other way. So you can see that, in the bottom kind of left here, I've drawn this pattern here, and then I've just basically trimmed it to a rectangle, and then you can see it up in the top right-hand corner there. So the thing with these kind of lattice forms is that the more kind of crossed they are, the stronger that it is. So you don't want kind of a line that is like basically by itself, like not attached to anything and unsupported. That's not good because obviously it could be break at that point. So the more kind of mesh, quote unquote, that it is, or the more connected and the more crossed it is, actually the stronger that that particular piece is. Okay, so yeah, actually before, I would say maybe about 3 years ago or more than that, maybe 4 years ago, I wasn't actually doing a lot of 3D printing. I was actually using the CNC in a very basic way. So I would just make basically a vector line. That's what you saw in the CAD file there. So it's just a line. And then the drill bit that was on the CNC, it would give me a thickness. So the CNC, I mean, there was a V bit, like there's a bit that's like this, obviously. So it runs along the wood. And so it creates that V groove there. And so, it was basically just flipping the vector drawing the other way to basically get the back and the front. And then I'd make some registration dots on how it would land. So this was not a very actually accurate way of making these forms, just because, if the bed wasn't level, that's a problem, or, something was not completely aligned. So here's a piece here. So it's like, using an air compression mold, using the slabs, and because they're made out of clay that you hand build with, it's easier to actually bend it into shape. So if anyone has known slip casting, it's very difficult to kind of bend and twist like a slip cast piece because the clay is not formulated to do that. But with hand-built slabs, these are slabs technically, you can really bend it and kind of shape it into some sort of form. CNC engraved MDF model. So this one was done in China. And the quality was quite good, but it takes a very long time to do something like this. So this is about 10 inches square-ish. And I think it took about 2 days on the CNC bed. So, with the CNC, you start with a big kind of rough bit, obviously, then you go to a smaller bit and maybe a smaller bit after that. So there's so many steps actually to get something like this off of like the CNC in comparison to obviously the 3D printer, which you can get something like this and not have, wait several days necessarily. So another kind of way of making the model is out of foam. So for this, actually, I just carved the negative shape into foam and obviously cast plaster on top of that to get the form. Okay, so you can see here, actually, there is 4 dots that are on the corners of this piece of plaster. So actually, I would drill holes there and then also use a dowel to register, because it's a 2-piece mold actually, so register the top and the bottom. So there's a lot of kind of issues and problematic things with that. Registration is something that I've really dealt with a lot when like dealing with these forms, but I will talk about that like a little bit later on. So you can see obviously the CNC is drilling into the foam. Here it's just it's quite a rough cut. So this is actually one of the pieces that is in the show. So this actually, there was obviously a pattern plate that was made. I made these slabs. And then, yeah, so you can hand build with them just like you hand build with regular slabs. So, slip and score, put the slip on, and then join it together. I am not particularly a great hand builder, but this was a way of like getting kind of like a volumetric form, relatively kind of large in some sort of way that was, not tiles slotted together. It's an actual kind of volume, right? Whereas the work before, it was like tiles, that flat forms that were slotted together. So it does have a very, very different feel in terms of like, how you look at it and how it's received as well. So this is the piece that is in the show. So it, I forget how many modules there is. I think there is maybe 14 here, 2 layers that are just stacked, they alternate kind of stacked to create a column as well. So this is really, early on when I was here in Texas, maybe about 2.5 years ago now, that I started doing or building these kind of volumetric forms. Okay, so this is a piece that is also in the show, the big cube, which was really a huge kind of technical challenge to make. So, I was interested in making like a larger sort of lattice form that you could kind of slot together as well. So this was like a whole summer basically of trying to figure this thing out. And then obviously you can see that there is so many different kind of shapes as well. So I actually built this twice. One time, like this top square piece was actually 4 pieces, and that didn't work. So then I went to build it as one as well. But anyways, it's built of like many different kind of lattice sort of tiles here. You can see on the left here that they're supported by clay to put it into that kind of position. And it's really tricky because, basically all of these slabs need to be about the same sort of wetness when you put it together. And it also has to be put together actually relative, like pretty fast. So like I have to basically join everything together maybe in one day. The finishing can come a bit later, but yeah, so you have to like put it together actually pretty fast, and especially if it's summertime, it's kind of a little bit hot. That's also problematic as well. But anyways, these kind of large holes here, actually on the top right one, you can see that there is this sort of cone-shaped square, faceted shape here where that pillar kind of slots into as well. So anyways, inside of here, you can see that there is braces to obviously keep that wall up as well. Otherwise it would warp. Okay, so here's the piece here. So you can see that there's 2 kind of large sort of square pieces on the top and the bottom. And then the middle ones are actually 4 kind of columns that slot together as well. So, making all the slabs and things like that takes time, and also joining it together. But the real work is actually cleaning all the holes, which is actually still like most of the work is cleaning the holes. So, all the finishing work actually does take like a really long time to do. I have, had a couple methods of dealing with that. Obviously, you need to make the mold actually quite as well as you can, so you don't have to do a lot of cleanup. Another thing that I have been doing for another piece is that firing to 022. So that is really soft bisque. And then taking a file, sometimes actually taking a Dremel, and then actually grinding that as well. So yeah, so cleaning at the green stage, especially when it's wet, obviously it's best when it's done when it's kind of leather hard, but it's a bit fragile. But if it is this to a very low temperature, you are not constricted by kind of wetness or the dryness of the piece. So, okay, installation and hardware. So I mentioned before that that's, 3D printing hardware is something that's becoming more prominent in my work, and it's also quite important as well. So when I'm dealing with like a lot of objects or a lot of modules, I do want the easiest way to kind of install it or kind of adjust it if it's on the wall or if it's hanging. Obviously, if you need to unscrew or screw back and a piece of hardware in the wall and you have 500 of them, you would like that to be as convenient as possible. So this is one thing that we were experimenting with. I think last year I had made a tile piece. So this was actually my husband's idea to make this piece of hardware. So it actually is like a lipstick case. It's resin printed, and you can see on one side that there's a hole there. So actually you can screw the one in the top right-hand corner into the wall, and then you can put the tile in, and then the lipstick case part goes on top of it. So you can see right here actually how this back part, if you look at the left image, that's screwed into the crate. I was just using that as a temporary thing, and then the top part, like the lipstick case, is basically pushed into the center there. So so it's allowing for the tile to have a little bit of a gap or not be flat against the wall, and it has a little bit of lift, and obviously it's part of the design as well. 3D printed hardware. This is for that H piece. I don't know if I have that picture of that piece here. Anyways, so these were printed hardware for the tiles basically to sit onto the floor. You can also print pins. The little kind of holes in this hardware as well is where to put kind of museum wax, so you could stick it basically onto the floor as well. Yeah, oh, okay, I do have a picture here. So this is kind of like the H kind of piece that I was working on here. So you can see that there's these little kind of clip, like, I wouldn't say clips, but little types of hardware that you push into that kind of groove there. So that tile is basically held in place. And then there's pins that are on those corners as well. So this was, I wouldn't say this is an extremely successful way of putting things together, but it did was a good stepping stone in terms of learning how to use hardware to put together objects to make an architectural installation. So this is just like a little bit of a close-up of this. So in previous kind of installations that are done or connecting modules, this is the way that I had done it. So, the ceramic has a hole in it. It is oversized and in connecting two pieces. So I use something like a pin, or you can use like a nail or some other type of hardware object. Use beeswax basically, and then wrap it and then stick it between the ceramic, the two pieces of ceramic. So, as you might know, like ceramic holes never line up perfectly. So, you can never make something to fit perfectly into another thing. So that's always something that you need to plan for. So the pin would give some sort of stability to the joint. And then the wax actually is soft enough that, if it's not completely lined up, it's still okay. Okay, so I have a mold making video here. And I think I can do a new share. Zoom is great. Okay, so I hope you can see this video here, and then I will play it for you. So I think I just do an introduction on some of my work, and then you'll get to see the process of me pouring the mold, making the mold, and also doing a press for basically a one piece mold. So later on after the video, or later on in this talk, I will do, I have a 2-piece mold that I'm going to press for you. Okay, I'm going to play the video. Hi, everybody.
Elisa, I think we're not getting sound on our end. I wonder if there's a way to like stop the share and then start it up again, but there's 2 little check boxes to optimize for that.
Okay, let me try again. Okay, I'll share. Do you hear something now? Could you see the can you see the image?
We can see the image, that's fine,
Oh,
yeah.
you can see the image.
But
Okay.
there's no audio.
Oh, okay. Hold on. I think no, this is 100%. Let me stop share for a second. Maybe it's something with my video settings. No. There should be little check boxes when you hit share screen. Okay, let me try again here. Oh, I see it. Share sound. Sorry about that. Yes, thank you. And then it says optimize for video clip, but I'm not sure if I need to do that. Okay, share.
It'll help.
Okay, and let's try that again. I think it should be okay now. Hi, everybody. My name is Eliza Au, and I'm a ceramic artist who works with clay lattices. This is an example of one of my pieces. So it is made out of layers of tiles, which are first high-fired and then slotted together, glazed, and then low-fired. So the process of this piece started with something like this model, which was 3D printed. So this shape, I will actually make a plaster mold of and make these individually out of clay. So let's get started. Yeah, so I think I can pause and just actually talk a little bit over the video because most of this video doesn't have any type of sound. So this is actually all the types of tools that I use, which are pretty common. I mean, you got your bucket, your rolling pin and such. There's only actually one yeah, so there's only one piece of that equipment that is a little bit more specialized, which is a mold duct tubing, which is circled right here. So it's called it's from Axner Pottery Supply, and it's usually used for the ram press and the air compressor. It's not pictured there. Yeah, so you can see that there's a 3D printed model. And then there's a wire mesh screen, which is made out of something, I think they call it hardware cloth. It's not, might be called chicken wire, but it's called hardware cloth. And this is about 1 centimeter squared. Yeah, so you can see the wire mesh is bigger, obviously, than the 3D printed piece. I'm just going to go back just one bit. Okay, so it is about 1.5 centimeters of spacing between your model and then also the wire mesh, the top of the wire mesh. So that's really important. You know, all the measurements that are shown in this video need to be quite accurate. Otherwise, you may have some issues later on. So you can see using zip ties there, I'm weaving the mold duct tubing on the bottom side of the hardware cloth. So you can see apply Vaseline to the model and the plexiglass surface. You can see, obviously you want to work on a surface that is like either stainless steel or you can have a laminated plywood. You know, obviously plexi doesn't absorb any water. So these 4 actually boards are called Caudal Boards, which create a container which you're going to pour plaster into. So you can see place Caudal Boards around the cage. So it's not touching the cage. There is a little bit of space between there. So yeah, you can see it's marked at 4 centimeters. Make sure that the tubing is exiting how do you say, exiting the mold there, right? So actually, this is actually going to be sticking out of the plaster. That's where you're actually going to blow the air into. So you can see that you're preparing the plaster here and mixing it. So just a note in terms of, I don't go into detail into mixing plaster here, but in terms of the plaster and water ratio, it is 100 parts plaster to 60 parts water. So for a usual slip casting mold, that's 100 parts plaster to 70 parts water. So that's what the slip casting mold is. So it is a little bit more dense. Yeah, so I'll just keep on going here. So yeah, so I'm just using my hand to keep the net from floating. And I'm pouring the plaster in. So then the plaster is basically enveloping the mesh inside it. So you can see there. And then at some point, actually, I'll take my hand out and usually I just like shake the table slightly. So you can see that the plaster is set and then the piece of tubing is sticking out. So I just cut off that little piece of excess right there. So I removed the plaster from the Caudal Boards here, cleaning up of the mold as well. Yeah, so any kind of edge, and then just using a knife or a tool to take the model out of the plaster. Yeah, you can see this one doesn't have any backing for the model. Yep, clean up all the edges, kind of removing any of the undercuts because that might grab a little bit. So you don't necessarily need to use a 3D printed model. Technically, you could just make it out of clay or anything else. That is obviously okay for a one-piece mold. So, okay, so pressing the mold with clay. So you can see I'm preparing the clay here. I'm rolling like a small slab. And then I'm going to pound the clay into the slab. And I'm just gonna take a rib and kind of take it off the excess clay. So you can see in this mold, actually, there are no registration marks. So it's gonna be actually flat on one side. Scraping off all the excess clay. So you can see now that all the holes are basically perforations. They are cleaned out. Yeah, so you can see that there's the clay inside of the crevices now. Okay, so releasing the mold. So I use an air compressor with a blowgun to around 30 PSI. So you really want to make sure that generally I never go over that. You know, I have blown up quite a bit of molds before because, you know, if the air compression is too strong, obviously it will break your mold, or if your mold is really wet. If it's really, really wet, it is quite soft. So it won't take the pressure very well. Yeah, so you can see actually here there's a piece of cloth, and I've used these as spacers in order to turn this mold over to drop it. The piece of cloth is actually pretty important. You can't drop it on just like a piece of wood because it's going to grab to the wood and it's going to shrink and it's going to crack. So I found that, you know, using a piece of cloth that is fairly flexible, like a bed sheet kind of fabric, is really good. The more kind of stretchy it is, that's the more better it works, because you can, you know, when the clay actually hardens, you can kind of pull or stretch the fabric a bit, and it will release the clay from the fabric. So I'm turning the mold upside down onto the spacers. So you always need like a little bit of space between the actual mold and then the surface of your board. So that's important, right? Because if you put the mold actually directly on the board, it won't just like release itself. It will still stick. So it does need that little bit of space to actually drop down. So you can place the blow gun on the opening, and then you can see that it's starting to expel all the bubbles from the water from the mold. So it's really those bubbles that are actually pushing that piece of clay down onto the surface of the board. So for something that is like really fine or lattice-like, you do really need to release it pretty much immediately, because, obviously when clay is in a mold and it shrinks, it will crack. So just getting the water off of that. So you can see that the lattice has released. So, yeah. Yeah, so this is just, a shot of all of the process here. You have a 3D printed model, you have your plaster mold, and then you have your actual clay model as well. So another thing to note is that this process really only makes like a lot of flat things. I've had students before try to make volumetric things, but they don't really work too well, because when it releases from the mold, actually, it is extremely wet. So in terms of making like, 3-dimensional things, it's better to just release it as a slab. And then, if you want to put it over a mold, you can drape it over a mold in some sort of way. Great. Okay, so I'm going to stop share here. And let's see here. I think I can actually sit here and actually, I'm going to switch to my other screen right now, Matt.
Okay.
And we'll see how that goes. So just give me a moment.
Sounds good.
Oh, can you hear me now?
Yeah,
oh, you're muted, Matt.
Yeah, we can hear you perfectly well. And I
Okay.
guess if anybody is having trouble seeing Eliza, you can pin this video. I think it may be, or maybe the audio is coming from this video stream.
Okay. For some reason, the phone volume, I guess it doesn't matter too much as long as you can hear me.
Yeah.
But my volume is up kind of all the way. Yeah, but I can't hear you. Like you're a bit faint, but that's fine, I think.
Okay.
Just as long as you can hear me. Okay. So I'm just going to talk about a couple of things. So you can see here, actually, sorry, I'm just going to come up closer to the camera here, and hopefully can you guys see this?
Yeah.
Okay, so this is something that I'm working on in terms of making a hanging piece. So this is the screw, and then so there's actually two pieces here, right in here. So this actually moves up and down on this kind of cord here. So there's a ceramic piece that's going to hang right here. And so it's adjustable. And so this is actually a screw and a bolt. You can see right here.
Wow.
Right. So this actually screws into this one. And so if I tighten this quite a lot, actually this will not move. This is quite stiff. So what this allows me to do is, like, the ceramic piece is going to be on here, that I can unscrew it slightly, right? And then I can adjust it, and then I can screw it back on.
Oh, that's
like
cool.
Yeah, I know. It's cool. Like, yeah, I've been working on this for quite some time. I'd say maybe like at least like half a year, kind of more than half a year, actually, off and on. My husband just recently made the final kind of touches on that. But this is actually resin printed. Before I was printing it with a filament printer, but this is much stronger because like the filament printer, actually, if it's in heat, it will like deform very easily. So this is also quite heat resistant as well. So anyways, yeah, so this is something that I'm working on. I'm pretty excited about that because I'll see the results pretty soon, actually. Okay. Okay, so I'm just going to talk about, make sure. So these are some of the 3D printed models here. So you can see that I've printed it in 4 kind of sections here, right? So this is for one part of the mold. And then you can see actually, I'm going to hold it up a little bit closer, but right here, right in this area, that's a 3D printed key right there. So, you know, yeah, so this is actually going to be one part of the mold, and then the other part of the mold basically has the reverse of this key. So this is one part of the mold. And then this is the other section. So this is for a 2-piece mold. So you can see this is the other one here, right? And so if you look at this key, you can see it's kind of the opposite as well, right?
Yeah.
Okay. So this pattern is symmetrical basically all the way around, right? It's a square. It's I guess 4-fold kind of symmetry here. Okay, so you saw me make a mold. So this is one of the pieces that molds that I made from actually the first 3D printed model that I showed you. So you can see that there's the keys that are inside of here. And then on one side, actually, there is a hole. Might be a little, oh, sorry, it might be a little bit difficult for you to see, but there's a little hole that is right there where I'm going to blow air into. Okay. Okay, so I'm going to start to, actually, I'm going to show you the other part of the other piece of the mold because I've already pressed that, and I'll show you how I pressed this side that I just showed you. So this one's already been pressed. You can see that the clay has been put in here, right? It's been scraped off. This is basically ready to go. So unlike the model in the video, this is a 2-piece mold, right? So whatever comes out, actually, it's almost like a round kind of extrusion. So I already prepared like a slab as such. And I'm just gonna make it smooth. I'm just gonna take a rubber rib and kind of smooth this out. There's a bit of air bubbles here, but that's okay. Okay, so then I'm going to put this over my mold. Just move my mold kind of into the frame here. So parts of the pattern are not covered by the slab, but that's okay. I can just cut off a little bit of the slab and kind of patch it a little bit. So obviously you want to work with clay that is a little bit softer, and you do want to roll the slab that it's fairly thin as well. Right. So that just makes it easier on your hand, obviously, so you don't have to be scraping so much clay off. And especially if you make a lot of these, it's just easier on you that you don't have to spend a lot of time scraping a ton of clay off of the surface.
Elisa, these are a little bit like ram press molds.
Yeah, so it pretty much is. I actually have never personally done ram press, though I have seen it very early on when I started ceramics. I don't know if people are familiar with the ram press, but it's like a big kind of machine that has a mold on the top and the bottom, and it kind of compresses the clay like that. And it does, I mean, that's what the tubing is made for. It's made for a round press. But this is really kind of like a studio, quote unquote, version of that round press.
Yeah, I love seeing it this way. And I guess I never knew you could do that with, so this is #1 pottery plaster. It's not hydrocal or densite.
Yeah, it's #1 pottery plaster.
Cool. Wow.
Yeah. So I'm just using like a rubber rib like this. It's a little bit more stiff. I'm using the curved part here to just take some of this clay off. I've also used kind of a wooden rib as well. That works well.
Mm-hmm.
Wooden rib.
And I guess those 3D printed models that you start off with, they've probably got the artifact of the tube, well, the artifact of the plastic being laid on next to itself. Does that end up being hard to clean up later on in your mold, or do you clean it up before you cast?
Sorry, the 3D printed parts?
Yeah, all those little lines that it leaves on the surface of things. I can imagine that kind of being tricky to do.
Oh, yeah. That's a good question. I actually don't clean it up because, I mean, you know, where the extrusion is, it's, I mean, obviously it's so fine wherever that little part is. So I don't actually clean that up, but the glazing, when I glaze it, it actually covers everything. So you don't really see that. I think in some cases you do see the lines. It doesn't really bother me that much, though I know that people are a little bit particular about it. But obviously it's easier to get rid of the lines if you're like sanding a flat surface or a rounded, like a bowl or something. Obviously with this would be really hard. If you were super picky, you could do like a resin print. But honestly, it doesn't, I mean, after I glaze it, you really don't see anything. Like the glaze is thick enough to just hide everything, basically.
I like the lines.
Yeah. Yeah, so for pressing something that is actually bigger than this, it could take me actually up to an hour just to scrape away the clay.
Wow.
We also use something called like a bow as well, which helps to get some of the clay off. Actually, I have it here. Like a bow. You could see that. So that helps as well. It actually helps if it's a little bit of a larger kind of chunk. But I do want to make sure that I'm not, like, as much as possible, not damaging the surface of the mold, because every time I like scrape, it is actually eroding the plaster away. So some molds that I've like used a lot, this coil is actually getting thinner and thinner because I'm scraping off the surface of that plaster.
I'm just getting a note here from Linda. We do have fragments of your work, Eliza, in our teaching collection, so our students can have a look at that when they're in the studio. It really is unbelievably.
Yeah, I don't remember what I did, but yeah, I did visit Concordia. Oh my goodness, I can't remember. 4 or 5 years ago, or I don't know how long that was. That was a long time ago now. Yeah. At least 4 years ago. I can't even remember what I did actually. I might have done something like a demo, maybe.
This is such intricate work to dry. I could imagine it being really either tricky to dry. Maybe you address it with the type of clay body that you use, or maybe you've got strategies. I mean, you've got those shrink slabs that you dry this on, but is there anything special that you have to do to make sure you don't get cracks in the lattice work in the middle there?
I mean, the type of clay really helps. This is it's a stoneware clay, actually, that we use in at school. So obviously the type of clay really helps. But also it's like, I release it almost immediately. So I don't really have as many problems with cracking because it's released immediately. After it kind of dries and I remove it from the cloth, sometimes I have to be a little bit more careful, but generally there hasn't been that many issues. Like before I used to try like paper clay. I also tried how do you say, nylon fiber as well. And that's not really great because if there's fiber and I'm like doing this, like there's hairs that are coming out and it's like, it's a bit annoying to deal with. So that's not so great. Though it does help with the green strength, I think a bit, but not a ton. I don't know if it's because it's thin or I don't know, but so I haven't been using kind of any sort of fiber at all. Though it might be like good for joining slip and stuff, but I haven't tried that as well. So anyways, so you can see that it's pressed right now. And I'm just gonna put all the clay to one side here before I start to press. So yeah, so registration was really difficult for me. Obviously, because if the top one falls onto this, and if it's misaligned, it's very difficult for me to correct that. I can put some water on, like before I drop it, I put some water down on the surface and it helps. I can shift it a little bit, but obviously that's pretty nitpicky to try to solve something that is so delicate. So I usually like to just put a bit of water over this, and that just helps it kind of release a little better, though it's not always completely necessary.
There's one question in the chat here just asking about plaster chips and stuff like that as you scrape. Is that something that you've run into, that you get plaster chips, or you concern yourself too much about that?
I'm not so concerned with plaster chips. There has been like a little bit, but generally it's not like enough that it will like break something or cause any cracking really. Yeah, but actually the first kind of pull or drop from the molds, yeah, it does have a little bit of plaster in it. So, okay, so let me try it. Okay, so this is 1/2 of the mold, and I did write a cross right here. I don't know if anyone can see that. Anyways, there's a cross right there, and then it lines up with this cross here. Though, but because this pattern is symmetrical 4 ways, it shouldn't matter too much. But there are some patterns, mold patterns that I obviously need to line up properly. Okay, so that actually key has kind of set into the top there, and there is a little bit of a gap. I'm not sure how much is visible on your end there, but there's a little bit of a gap right here between the 2 pieces that is about 3 millimeters, I think. So that's really important, obviously, because it needs basically space for it to drop down. Okay. So I do have a blowgun here, air compressor. So it's actually pretty gentle. I have an adjustment here on this actual gun, but it's around 30 pounds of pressure or less. And when you squeeze it on your hand, it should be kind of gentle, not like forceful, okay? So it really shouldn't take a lot of pressure to push the water out of this. So actually I could have increased the pressure just a little bit. It is coming right now, but I'm just going to increase the pressure just a tiny bit. Okay, I'm just gonna mute this because I think the air compression is gonna, I have to turn it on and it's gonna kick on, so just give me a moment.
Okay, thanks, Elisa.
Oh, okay, sorry. So it looks like the mold was not quite wet enough, but that's fine for just to show you. So some of it is actually stuck a little bit into here. That maybe actually this needs to be soaked a little more, or the pressure needs to be kind of adjusted. But anyways, if it was a successful press, some of it is actually kind of lined up. I'll just kind of go ahead and tell you what I would have done next. So after the pattern is actually released here, I will just kind of use a sponge and kind of pat it down kind of gently. And then I will prepare the board that I'm going to drop it onto. So this is actually a piece of drywall here. So it's best to drop it on either a piece of wood. Drywall is great because it keeps straight after, you know, it doesn't really warp, whereas wood actually warps pretty easily and over time. So this is actually like a piece of bed sheet kind of fabric. You can see it's pretty stretchy. And I'm actually going to soak it into water and just wring it out. So I found that, you know, just making it a bit wet, it helps it actually, when you're dropping it, not stick up to the mold. Like it just keeps it a little bit more flat to the surface. I'm just kind of tucking that in a little bit. So you can use a big board, and for my smaller molds, like you can drop several of them per board, okay? So this mold actually has been designed there. You can see that there is actually feet. There's actually feet on this mold here, right? So I don't need to put spacers because the spacers are technically, they're already built into the mold, right?
Are those they're the registration marks from earlier, or those are?
Yes, correct. Yeah, there are the registration marks from earlier. And then they also act as a spacer here. For drop there, yeah.
Love that.
Okay, so this may kick on. I'm gonna mute again because then the compressor is gonna kick on here.
Thank you for sparing us of the sound of a compressor.
So yeah, so you can see that it's been pressed.
Ah, fantastic.
So yeah, so actually the first part of the mold kind of failed because the compression was not constant. I actually turned it off and tried to push it because I didn't want that to kick on. So if I had the compressor on for the first drop, I think it would have been okay, but probably I was like applying pressure and the pressure was just going down. So it was like, so it wasn't constant. So that might have been part of the problem, but it doesn't really take too long for it to drop. If you do see like the water bubbles coming up and then the pressure is correct. Yeah. So for this, the pressure, I just adjust from the gun, but you can also adjust from the actual dial that is on the machine. So great. So that's the demo of the pressing, and I'm happy to take any questions if people have them.
Thank you, Eliza. That was so generous of you to show us all this technique and really cool casting process. I know that I've often kind of wondered a little bit just how you managed to get those delicate forms or cast that kind of lattice work. And so it's nice the way that you end up doing it. I'm going through the chat over here and seeing if there are questions, which I see there's a question from Linda. What's the biggest piece that you've made with this technique?
Okay. Actually, I'm going to switch over to the laptop just because it's easier. I can hear you guys better. So just give me a moment. I think I can.
Oh, can you hear me now?
Yeah, we can hear you perfectly.
Oh, okay, great. Awesome. Maybe I can double skip. Oh. Pin. Oh, okay. Oh, okay, great. What is the biggest piece that I have ever pressed? I think it was something like close to maybe 19 or 15 inches square, maybe 18. I think it was around 18 inches square. And so at that point, actually, the mold became massively heavy to deal with. It was really, really hard on me and my back. So someone would have to come in and like help me pick it up and like turn it over. So it's also because the mold has to be used when it's quite wet. So then there's a lot of weight. I don't particularly like having a mold that enormous. Also, if there's like several pieces that are in there, I've had 3 shapes inside of a mold, and that was already very difficult to deal with. So I hope I answered that question.
Yeah, no, that makes sense. There's also, you mentioned that wetting the mold and the weight of that. There's a question here just about that. And so do you soak the mold in just a bucket of water, or you spray the mold before to get it wetted correctly? And how do you know when to stop, or is there a sort of too much is too much?
Yeah. So it is a little bit by touch, and it is too wet when the surface feels like it's like there's water on the surface. So when you actually touch it, it should be kind of cold, but it shouldn't have like basically water on the surface. Then you know it's waterlogged. And these molds actually were pretty much completely dry this morning. So I actually put it in there for maybe like 20 seconds and then like took it out. And so it's actually better to be a little bit more on the dry side than the wet side, because obviously it is it weakens it. So yeah, and I really do it by feel. Like there's no really, I guess, empirical method of doing it. It's just like touching it a little bit with the air compression too. So I know when it's like it's gonna like, it's too wet or it's too much force or something like that. But yeah, but the compression is usually around 30 pounds.
Mm-hmm. It's nice to see also the kind of hardware that you're talking about, custom building. I guess it's something I hadn't quite thought about like that as this other possibility. I usually, like you described, will go through maybe the bathroom aisle at Home Depot or something like that, looking for things to reverse engineer. But I guess my question to you is like, these are really complicated things to put together. When you shipped everything to the gallery, did you have stuff pre-assembled, or do you have instructions, or how do you deal with the assembly of everything and shipping stuff out? Do you send extras in case something breaks? How do you approach that?
That's a good question. The things that were sent to the gallery are not that complex to put together. But there's some other things that are a little bit more difficult to do. I know that some people have done like videos. I think one of my colleagues actually, she shoots a video of how to kind of put it together. That's a really good way of doing it. I think actually for the shipment that I sent to you guys was I had a QR code. So there's a QR code that goes to basically a Google Drive. And then there's documents or videos or whatever in there. So you don't like lose a piece of paper somewhere. It's like you can just scan it with your phone and basically you'll have access to it. So that's good. I mean, it's always obviously good for you to go there and set it up yourself. And then whoever is there, they take it down as well. So.
Oh, the QR. That's a really cool.
Yeah, it's a good way to do it. Yeah.
I also I guess the pipe function or the pipe command in Rhino is one that I don't use very often. And that makes me just think, like, what are some of the commands that you find yourself using a lot in the work that you do?
Yeah, that's a good question. I do pipe and then also sweep one. maybe sweep 2, but sweep 1. So sweep 1 is like, for instance, if I wanted the extrusion to be like a diamond shape, right? So then I would like draw the line, and then I'd put the diamond shape on the line, and it would make the diamond shape, like sweep it, like that, make the extrusion diamond shape. More recently, I mean, most of my sort of extrusions are kind of round, so then the pipe is fine. Yeah, I think it's that. Oh, Boolean, obviously, Boolean union, Boolean difference, Boolean split. So when I'm drawing something like, the pattern plates that I was showing you, and it's like they're 4 pieces, that's done with like a Boolean split as well. So, I mean, it's not like, someone who does CAD for a living, these are very simple, actually, functions. Obviously, they're more complicated for artists. Lattice forms do get really tricky to draw, just in terms of joining them together. So there's some things about drawing those particular types of shapes that I've learned. There's some issues where things don't kind of join together. So yeah, so on the back end, there is a lot of technical stuff that I need to learn. But yeah, it's usually the same types of functions that I'm using basically over and over in Rhino.
Yeah, those are some of my favorites too. I guess the Booleans are all a well-known family of commands. I guess I feel like I'm scratching the surface of a very complex tool with that. And so it's why I ask the question. And so when that lattice work comes out of, so I can understand needing to release it from the mold quickly, but when it comes out, you don't have issues with warping or cracking.
There is issues with warping. I mean, just because it's thin. So depending on what I build, if it is a box or whatever, the top does start to like go down. There is movement, more like, because I'm my building skill rather than the clay, very honestly. But there's as much with cracking. So, if everything was basically made at the same time, or maybe like the next day or something like that, everything can be joined quite easily. But you do get into a lot of issues if, for instance, you make a tile, one day, and then 3 days later you make another tile, because they're drying differently. So actually you will see actually quite prominently that, the tile that you made earlier is actually smaller. So if you're trying to like build something that is more accurate, that's a problem. Yeah.
Mm-hmm. And there's another question by Susan Copeland in the chat here. What originally inspired you to start working with lattice forms?
Oh, that's a great question. I'm not really certain. I mean, like usually in my slide presentation, I think I might have, I don't think I showed it in my other slide presentation, but like basically when one of my first classes at Emily Carr in ceramics, like I made this box, and then the box had like this like pattern, like a lattice surface on it, like a lattice, I just cut out the shapes. So back then, actually, that kind of idea was still there. I guess it was more subconscious. But I don't know. Like, I think it's also because it's such a technical challenge. Well, like, like how are you going to make so many of these perforated forms that are this thin, right, to make whatever? So, and, it is, they're related to architecture and having that architectural experience. And I think a lot of contemporary architecture, really works off of that idea of the wow factor. Like, wow, like you made this to stand up. Like, how does this stand up? Like, so there is this sort of beauty about the technicality of things that I really do enjoy. And of course, that connection to sacred space and, historical architecture and, historical artifacts that are made in such an elaborate manner. So, yeah.
That's great. Thank you. There's another question here from Linda. Does 3D printing clay directly, does that hold any appeal to you as opposed to the milling or the kind of printing and casting?
Yeah, that's a great question. I have done like a little bit of it before when I've been at a residency, or when I was in China, I was using kind of like it's a tube for adhesive that you attach to an air compressor. And that's really tricky because the air compression is not constant. It's like, it like gives you force and then it's like kind of dies down and then the air compression kicks on again and it's like lots of pressure. And so, and we did buy more recently like a smaller kind of ram kind of tubing. I mean, this is just my own personal research from some place called Stoneflower. I think that's where we got it. And I haven't done much research on that. I don't know if I'm like really, if that would become like a main thing in my practice. Just because with 3D printing clay, it's like, you know, you have those lines of where that extrusion is. I mean, I think people are quite familiar if they've seen that work. So, you know, so those like extrusions, that extrusion is so prominent. And I feel like if that's not part of my aesthetic of my work, then it might not be so appropriate. However, I do think like, you know, there's some really interesting stuff that's coming out of that technique that I personally have not done a ton with it. So.
Mm-hmm. Yeah, I guess it does strike me that the printed objects end up being kind of unique. They're like a monoprint, whereas a casting off of a print there's a real different kind of approach to working in there. Well, thank you so much, Eliza, for your super generous demonstration and this chat near the end. It was great to hear you talk and to see your work in the show. We've got a couple more XYZ events coming up. We've got a demo tomorrow morning at 11:30 with Del Harrow, and then our roundtable discussion on Friday at 2 p.m. So I hope that everyone joins us for that. And thank you again, Eliza.
Oh, thank you to everyone. Yeah, I know it was a bit of a longer demo, but yeah, I enjoyed it a lot. So thanks for coming. We'll see you on Friday.
Yeah. See you soon and take care.
Okay. Bye.